Welcome to another session of Maths Fanatics 24/7. In this video, we're going to be looking at the fundamental counting principles and permutations. Okay, so on the first question, they say the letters in the word Johann, right? So Johann is made up of how many? Let's see, how many letters, ne? So you always create spaces equivalent to the number of letters that you have. So I have 5 letters, I'm going to create 5 spaces, right? Okay, are arranged in any order without repetition. Obviously, there's no letter that repeats itself. So this is the simplest kind of probability of permutations. Ne? It's so easy when there's no letters that are repeating. We'll do an example where letters are repeating. I'll just do it here just to show you how to do them if there's a letter that is repeating. Okay. So for now, let's proceed with this. Okay, awesome. They say, what is the probability that the word Johann will start with J and end with A? Ne? So I want to give you a hint that you are always going to use all the time. Ne? If they give you the condition with weights and letters, ne? You see, they say letter J, they already gave you the position of letter J. Ne? So you're going to cancel it out on the word because you already know its position. It's here. You just put 1. Ne? And then you know that the position of A, you cancel it there, you put it there. So the letters which the position is known are going to be cancelled, and then their positions, you're just going to put 1. So now I'm left with 1, 2, 3 letters, right? So it's going to be 3 letters to pick from. Then I'm left with 2, then 1. Then I'm going to multiply all this together. Okay, then I can easily see that this is factorial 3. Do you see it? That is factorial 3. But if you want, you can just use a calculator here. But because I'm seeing 1 times 2 times 3, this gives me factorial 3 here, right? And then 1 times 1 is just 1, so it's not going to change. That's what I'm saying. This is factorial 3. And then from there, this is only the arrangement, right? The probability always we need the total sample space, right? Obviously, we have 5 letters, so the sample space is factorial 5, right? So answering this question now, the answer will be, therefore, factorial 3 divided by factorial 5, which gives us, let's check on a calculator quickly, 3 shift factorial over 5 shift factorial gives us 1/20. So the probability will be 1/20. And then you're done with that question. Awesome. Okay. Now, guys, I want to show you, before we go to the next question, I just want to show you another example. I'll write it here. Let's say we had the word, let's say photographer. Okay, let's say photo shoot. Right. Let's say we have the word photo shoot. Right. And then we wanted the total possible arrangements here. So we want the total sample space first. So this is what you're going to do. You count how many letters you have. So I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So I have 10 letters, right? So it's going to be factorial 10. But in this case, there are letters that are repeating, right? For example, the O is repeating here, there, and there. So I have 4 O's in total, 1, 2, 3, 4. You always divide by the factorial of the repeated letters, ne? In this case. So T, there, and there. So factorial 2, you multiply. And then I have H here and there. So times another factorial 2. So this is how you're going to do it. If you have identical letters, do you see? So this is the total possible arrangements that we're going to have. The reason why we divide them by this is because if I switch this O and that O, it won't make a difference. It's going to be it's going to be the same as this one, basically. So we're avoiding to have double words which are the same. Does make sense? So that's why we're repeating by the factorials of the number of letters that are repeating. And the question will be specific here in the exam. They'll be specific. They'll tell you that same letters are identical. Are identical, or they'll say same letters are different. Okay. This one is for when same letters are different. Are identical. But the examiner can decide to treat this O and that O as different. Does make sense? So the total possible arrangements will now be just factorial 10. If same letters are treated as different, no need to divide. But if they tell you that same letters are identical, you have to divide by the factorials of repeated letters. And sometimes they don't say, just like on this exercise here. If they don't say, you always treat it as same letters are identical. Sometimes the examiner won't say if same letters are identical or different. If they don't say, you always treat them as identical. So you're going to use that method. I'm sure this makes sense. We can now move on to the next question. Okay. So they say the Lawrence family takes family photos. The photographer arranged 3 married couples. Okay. 7 children. Okay, 3 married couples. And 2 grandparents as follows. The couples stand husband and wife together at the back, as shown in the picture, and the grandparents in the middle, and the children in the other positions as shown in the diagram below. So we have married couples, grandparents, and children. How many different ways can the Lawrence family be arranged for the photo? Okay, so guys, this question, because we have 3 different groups of people. We have married couples, we have grandparents, we have children. I'm going to do this question separately. So we're going to do the arrangement of married couples, arrangement of grandparents, and children separately, and then add the answers together at the end. Okay, so how many people do I have on married couples? 1, 2, 3, 4, 5, 6. So I'm going to create 6 spaces. So I always create spaces equivalent to the amount of items I have. But these are going in pairs. Do you see them? They are going in pairs. So which means I'm going to have pairs here, because they are always going in pairs. Sharp. So remember I said each pair you treat it as one item of the entire group. So here I'm going to have 1, which is this pair, 2, and then 3. So I have 3 groups in total. Perfect. And then, but inside here I can have factorial 2 because there are 2 items, and inside here I can have factorial 2 because there are 2 items, and inside here I can have factorial 2 because there are 2 items. So the married couples are going to basically be factorial 2 multiplied by factorial 2 multiplied by factorial 2, and then multiplied by factorial 3. Do you see it? 1 times 2 times 3, it's factorial 3. Get it? And then married couples, I'm done. Now I'm going to do grandparents. Grandparents is just 2 of them. So grandparents is basically one item. So it's just factorial 2. Do you get it? Perfect. So here I have factorial 2. And then here I have that. Now let's do children. We have 7 children in total, and they can sit in any order. So this child can go there, that one can go there. They can always swap around. So here we're just going to have factorial 7. And then we just have to add this that and that together. Let's do that on a calculator quickly. Okay. So we're going to have a factorial 2. I'm starting with the couples. No? Factorial 2 times factorial 2 times factorial 2 times factorial 3. So married couples gives me 48. So I'm going to have 48 plus factorial 2 is just 2 for the grandparents. And then now let's do the last part. So we did this, we did that. Now we need to do factorial 7. Okay. Let's see. 7 shift factorial. Not that. Shift factorial gives me 5040. Right. And then let's see now. We need to add all this together. Okay, ladies and gents. So now we have to, here, put a plus. No. We don't have to plus them. No? They must be multiplied together. Remember, this is one arrangement. So you just have to multiply everything together, not add. I'm sorry about that. And then now when we multiply this, we're going to have 48 times 2 times 5040, which gives me 483840. So those are the possible arrangements that we going to have. So ladies and gentlemen, this is the last part of this section. Thank you very much for your time and putting effort for your studies. Please don't forget to hit the subscription button if you haven't done so yet, and to share with schoolmates, family, and friends. A luta continua. Thank you very much.